Hey, what's up guys? Today we're going to learn how to solve quadratic equations using multi-step factoring. So before you watch this video, you're going to want to make sure you know what a difference of squares is, and then you're also going to want to know how to factor a trinomial when the leading coefficient is 1. Alright, here it is. Okay guys, so today we're going to learn yet another way to solve a quadratic equation. And the reason this method is called multi-step factoring is because we're going to use two different factoring techniques in the same problem here. And this is a great way to avoid having to use the quadratic formula, but of course you can't always use this, and you'll see what I mean in a second. So we'll start off with a very simple application of this. So here we have a quadratic equation, and now the first thing you're going to want to do is see if there's a greatest common factor that you can factor out of this trinomial here. So in this case, the greatest common factor of these three terms is 2. So be sure that you realize that the greatest common factor is just 2 and not 2x, because notice how the 12 doesn't have an x attached to it. So we can't factor out an x from all three of these things, and so the only thing we can factor out is a 2. And so after I factor my 2 out, then I have to do the distributive property but backwards. So 2 times what gives me my 2x squared? Well, that's just x squared. And then 2 times what will give me a positive 10x. So that's going to be a plus 5x. And then 2 times what will give me a positive 12. And that, of course, is 6. And so now this is what my equation now looks like. And as you can see, this is now a factorable trinomial right here, where the leading coefficient is 1. And so we already know how to handle that. Now, again, your problem has to be, you need to have a greatest common factor to factor out in the first place. Otherwise, you're going to have to resort to the quadratic formula, or maybe even factoring by grouping. But if you do have a case where there is a GCF, then you're going to want to take advantage and use this method, because it'll save you a ton of time. So now that we're in this position, we're going to go ahead and factor this trinomial. So don't forget about your 2 out in front. And now I'm going to factor this trinomial into a product of 2 binomials. And this, of course, is just going to be x plus 3 and x plus 2. All right, and now we have a fully factored quadratic trinomial. Okay, we started here, and now we're here, and now we can just use the zero product property. Now, keep in mind that this 2 plays no role in the zero product property, because the zero product property says that if this times this equals 0, then either this needs to be 0, this needs to be 0, or this needs to be 0, right, in order to make that true. But 2 can't be 0. So we're just going to ignore the 2 and just pretend that either of these needs to be 0. And so, of course, x plus 3 equals 0 if x is negative 3, and x plus 2 is 0 when x is negative 2. And so these here are your 2 solutions to the quadratic equation. All right. Let's try another one. So these examples, just to save time, they're already set equal to 0. That won't always be the case. Actually, maybe on the next one, we'll set it up so that it doesn't already equal 0, just for some practice. But this is conveniently set up for us. And so the first thing you're going to do is try to identify the greatest common factor. So it will go into all three of these terms, and in this case it's going to be 4. So I'm going to factor out my 4, and then 4 times what gives me my 4x squared, it's going to be x squared. And then 4 times what gives me my negative 24x, that's going to be minus 6x. And then 4 times what will give me my negative 160, and that's going to be negative 40. All right. And then just like the last one, this is now conveniently a factorable trinomial. And so I'll keep my 4, don't forget about that. And now, since I'm multiplying, I need this number and this number to multiply to a negative. So I know I'm going to be dealing with one of each sign here, because that's positive and negative is the only combination that'll multiply to a negative. And then this is going to end up being, I need to add to negative 6x. So this is going to end up being a negative 10 and a positive 4. And remember, this factor out here is going to play no role in our zero product property. Another way you can think of it, guys, to help prove to you that this doesn't mean anything, is I can divide both sides by 4 here, right, to sort of cancel that 4. And then 0 divided by 4 is just 0 anyway. And so you'll see that I'm just left with that. And so, as you can see, this factor out here really does play no role in this. And now we see that x needs to be negative 4, right, to make this factor 0, or x could also be positive 10 to make that factor 0. Okay. And now, this one, we'll set this one up so that it doesn't equal 0 immediately. Okay, so say you have a quadratic equation that looks like this. Well, then we can get this set equal to 0 by subtracting 3x from both sides. And then also adding 126 to both sides. So that'll cancel, and I'm just left with 0 on the right side, and then I'll have all this stuff on the left side here. And so I'm going to get negative 3x squared minus 3x plus 126 equals 0. And now here is, you'll notice the leading coefficient is negative. And so we're going to want to factor out not just a 3, but we're going to want to factor out a negative 3. And so I have a negative 3 out front now. So I have negative 3 times x squared will give me my negative 3x squared. And now negative 3 times positive x will give me my negative 3x, right? Negative 3 times positive x will give me negative 3x. So we flip this sign. And then negative 3 times negative 42 will give me my positive 126. Negative 3 times negative 42 equals positive 126. Okay, so this is now our new equation. And as usual, this is a factorable trinomial. So again, I'm multiplying to a negative number, so I need one of each. I need a positive and a negative. And I need them to combine to a positive 1x. So I need positive 7 and negative 6 here, because positive 7x plus negative 6x gives me my positive x. And then again, you can divide by negative 3 on both sides if you want, or you can just realize that this doesn't play any role in the zero product property, and so x needs to be -7, or x can be +6 to make this a true equation. All right, now there's a couple of special cases here that I want to cover, and I want to show you that the multi-step factoring also applies to a difference of squares. And so right off the bat, this doesn't look like a difference of squares because it's not a difference of squares. But if you notice, there's a GC, a greatest common factor, between these two terms that we can factor out, which is 2. So I will factor out a 2, and then I'll end up with x squared minus 16, right? Because 2 times x squared gives me the 2x squared. 2 times -16 gives me the -32. And now you'll see that in these parentheses is a difference of squares that I can factor. And so I'll keep my 2 out front, and then this difference of squares, of course, just factors to x minus 4, x plus 4. And we now see that x can be positive or -4. All right, we'll do one more. So maybe this one's not conveniently set up for us. So to get 0 on one side, I will add 500 to both sides. And now we have 0 on the right side. And now I'm going to factor out, here the leading coefficient's -5, so I'll factor out a -5. And I'm left with, oh, sorry, that shouldn't be a negative sign. That should be x squared, and then -5 times -100 will give me the positive 500. -5 times -100 gives me the positive 500. And now again, we have a difference of squares here. So I will go ahead and factor that difference of squares into x minus 10 times x plus 10. And we see that x can be positive or -10 for that to be true. Alright guys, so again, this is a really useful set of skills to avoid using the quadratic formula when you can. And it doesn't always, you're not always in a position where you can factor out a greatest common factor, but it should always be one of the first things that you look for, because when you do, you save a ton of time. Alright, that's it guys. It's been demonstrated.